Alrighty. So, everyone that decided to show up here on time, thank you very much. If you not, now, this is a public service announcement. If you're walking into this class late, do not be a distraction. Do not come in here asking for questions that you most likely are going to miss out on. Ask me those things later on. Okay? I do go over stuff when you're not here. So walking in here and asking the questions that I just got done saying, at this current moment in time, I'm like, we started class with what? How many students? 4? That's not, yeah. And then come back and make me re-say everything. That's very, if anything, I would say unprofessional. If you're gonna come in quietly. I understand you're coming in late. I'm not giving detentions for tardies anymore. Or otherwise, most of y'all will be in detention every single day. I'm not doing that. You know what? I want you guys to understand, this is on you. But if you come in, please don't be a distraction. Yes, it is frustrating for me to have to keep talking and talking over people that walk in, have to hand out McDonald's, and, start a conversation. I know, but come on. Anyway, all right. Well, those people actually taking notes. Remember those things, the papers? Remember those notes that I gave you guys? Now here's the test. All right, here we go. Solving related rate problems. A person standing at the end of a pier is docking a boat by pulling a rope at the rate of 2 meters per second. The end of the rope is 3 meters above the water level. How fast is the boat approaching the base of the pier when 5 meters of rope are left to pull in? Assume the rope never sags and that the rope is attached to the boat at water level. There's a lot going on here. It's almost like this is probably one of the hardest problems that you're going to have. We have a person standing on a pier. You guys know what a pier is? Hopefully. We have a boat. We have a rope.
I'm confused. It's saying it's attached at water level, but then it's saying the end of the rope is 3 meters above water level. That's the end of the rope?
Yeah, he's holding it.
Who's the person? Joseph?
It's more like this. Okay, there we go.
We're trying to find how fast the boat is approaching the base of the pier, which would be meters per second.
Excellent. So, we have to figure out what we're working with. What pieces are moving? The rope, right? So, this is moving this direction, isn't it? This, is that moving at all? No, he's still holding on to the rope, isn't it? Okay. What shape is that?
Right triangle.
Very good. A right triangle. since that is a right triangle, a couple other things that I have. What was the information they gave us about the rope?
3 meters above water level.
It's 3 meters above water level, so that means that this right here is 3 meters, right? Anything else?
There's 5 meters of rope.
5 meters of rope, right? So right now, this value right here is 5 meters. What else did it give us?
Rate that it's being pulled
Rate that it's being pulled
in.
in, right? Okay, where's that going to go? Where is that changing?
Base.
It's not the base. What they say is actually coming in. The boat's coming in, but what the rope is coming in, right? So since the rope is coming in, that means this purple one right here is changing, isn't it? So I need to go through and I need to identify what I have here.
Wouldn't the rate that the rope is coming in be the same as the boat?
No.
Because that one's slanted.
Yes. Let me go through and label everything for you so you can understand. This is a right triangle, isn't it? And when we talk about directional in two directional, which all these are 2D right here, right? They're all 2D. They're not 3D. We don't have to worry about that right now. This is a two directional. I have an X value, which signifies my left and right. I have my Y value, which is going to be here. Call that one. Is going to signify my up and down. My hypotenuse, the hypotenuse over here, is going to be the R. Because in my Pythagorean theorem, it's always going to be x squared plus y squared equals r squared. Or whatever distance, or the hypotenuse. It's a squared, b squared, c squared normally. But in what we're doing, it's x, y, and r. But it's the same concept, x, y, and r. X is my left and right. My y is my up and down. My r is the radius of my hypotenuse. I'm preaching good stuff. You guys got that right there? So that formula, hopefully you guys could get somewhere. Okay. So, let's see. What is moving here? I got my, right here, this is moving. So that means I'm going to have a dr dt, right? Because the rope is moving. And I also have, so what was my rope moving at? So it's a dr dt. Let me clean this up.
2 meters per second.
Say one more time.
2 meters
2 meters per
per second.
second?
Yes.
There you go. What is the final thing they're trying to ask for here?
How fast the boat is approaching the base of the pier when 5 meters of rope are left.
Ooh. Okay, so now, how fast is it approaching the pier? So I'm actually looking for which one?
X.
X. So, but it's actually fast, so it's going to be my dx dt, the rate that my x is changing, right? So I'm looking for my dx dt. That's what I'm looking for in the end. When we went over these problems the other day, I said the number one thing is starting to set up your problem. Write out everything that you have, everything that you can get. It didn't tell us that this was a triangle. We had to go through and draw it to see what shape it makes. I had to have a formula for that shape to help me with that. The triangle and the Pythagorean theorem is going to be 90% of all these problems that we're end up doing.
And also know that x would equal 4.
It will. Why do we know that x is going to be 4? Louder, please.
Perfect right triangles.
Perfect right triangle. So we already know. So at some point we'll end up having to look at it and say, oh yeah, this is a 3, 4, 5 triangle. This is, okay. So this one is going to be that. I will have to solve for x later on. But yes, that's one of those things that you're going to end up having to do. Look at everything in the problem and try to list out everything we have. And that's going to help you. Sometimes you're going to have information that you don't need. Sometimes you're going to have extra stuff that doesn't fit. Look closely at what it's asking for. So I'm going to go with that one right there. Second, fit with. There we go. So now I have x squared plus y squared equals r squared. Now, I will find x. I will find, but I'm looking at the formula that I have. Okay, so take the derivative of this, but really think about what we have here in this picture. Take the derivative.
When you put 3 to increase the first dose, because it's a constant. When you need to put 3 to increase the first, it's a constant.
It's a constant, right? The y is a constant, isn't it? So since the y does not change, that is constant. So I could put that there because I know that I'm going to have my x moving and my r moving, the y doesn't move, so that's a constant. So x squared plus, that's going to be 9. So good call on that one. Now let's take the derivatives. I get dx dt
Okay, not over time.
plus 0, right? Equals
2r dr. Freaking, that's weird because we used to do like, dy over dx and dx is not the.
Yeah, because it's not. That's the reason why I kept pushing it, that you guys actually, or doing the implicit, write down all that is, all the time. All right, so do we know what x is? Ms. Becker, what did you say x is equal to? Why was it? Yeah, it is a perfect right triangle, 3, 4, 5. So I can plug in what I have. So I know if x is 4, this is going to be 2 times 4 dx dt is equal to 2. My r value is 5. dr dt is 2. Now, think about that last problem that we did. The homework problem that we just did. What's happening to my x value? Something, it's shrinking, right? It's shrinking, but where's that shrinking going to go? In my formula, it's my r. Very good. My r is shrinking. The rate that my r is shrinking. So I need to make sure that one's that's annoying. R is negative right there, right? So my dr dt is negative because I'm pulling the rope in. Length of the rope is actually getting shorter. So that goes over here, there.
Why wouldn't it be x?
x is a value, but once I solve for dr dt, okay, because it's not a negative x value because you can't have a negative distance, right? But we are going to have a negative dx dt because that one's also getting closer. So I will have a negative rate once I get there. Okay? All right, so this is going to give me dx dt is going to be negative what? Over 8, which is reduced by a factor of 4, which is negative 5 over 2. So now, what are we talking about though?
This is the rate at which the flow is coming into the
Okay, so now, but what I tell you about units,
Oh, it's gonna be meters per second.
meters per second, because it is linear. It's a speed coming in, right? So meters per second.
So when we took the derivative of x squared plus y squared plus y squared, that position, and when we finished at minus 5 over 2, that's velocity.
Where did the negative come from?
You're saying this right here is what?
And position.
Yeah, it's basically it's the measurement of each side, right? So we could have plugged in everything and actually used Pythagorean theorem to find out our x if we didn't see that it was a perfect, a 3, 4, 5. Okay, yeah, and then this is going to be a speed, which is my velocity right there, right? Okay. Now, what were you saying, Ms. Becker?
So then you just replace that with the direct.
Yeah, and that's what we were looking for there. What was key to starting this one off? Drawing it. Like 95% of all these problems that you're going to do, draw it. I highly recommend drawing it first before you even attempt it. What's the next thing I did after I drew it? Start plugging in all the values, start showing all your values, where they go back through. We went through the problem multiple times, picking out all my important information and putting it where it goes, right? Yes.
Could you have done this if you had solved for x with the x squared plus y squared plus r squared and then found the derivative?
Yeah. So he was saying that we could plug the values into the Pythagorean theorem if we didn't know what the x was.
Yeah, we would still have to solve for it.
How would that work?
What do you mean? So you're saying plug this in right now?
No.
Like plug in 4 right there?
I mean, if you solved for x, like x equals, what would that be? The square root of r squared minus
Oh,
y.
okay, so let's do this. So x squared plus 3 squared equals 5 squared. X squared. Is this what you're asking for?
No.
What are you asking?
So if it was like x equals the square root of r squared minus y squared.
Okay, so x equals the square root of
R squared minus y squared.
let me see, r squared minus y squared would be 5 squared, 25 minus 9 is 16. What's the square root of 16? It's going to be 4. But if you do it like this, yeah, you isolated it because you have x equals. You would also have to deal with your plus or minus. But in this problem, it's a real problem, so you're not going to have the negative distance.
So it would still get you the same thing?
One more time.
So it would get you the same thing.
Yes. So we still get 4. We still get 4, but if you did it like that, we have a arbitrary negative 4 also, because we'd have to test each one if you did it like that, because there's a reason why you have the plus or minus.
Okay.
because you have possible solutions when you do it like that. All right. Now, step by step, going through this, is it difficult? Is it tedious? Yes. Writing down the clues, writing down the information, sketching what you have, going back through it, that's going to be key to actually be successful at doing all this. Now, we have how many slides left? I think I have these last two, right? I have, yeah. So, and guess what? I'm going to leave this for when we get back, because by the time we get there,